Hello everyone. This video will get you started on homework 3. You should watch the video CA09 floating point before starting the homework. This homework is worth 200 points. You have a couple of weeks or so to complete it, but since it's worth 200 points, you really don't want to wait till the last minute to start coding this up. Here's kind of the big picture of what we're doing. We're reading in an input file and storing that into a buffer in memory. Here's the input file. It'll be in Piazza. Notice that it's just integers, 1 or 2 digit integers, each integer on a line. When you read this file in to your buffer, it's just going to be a sequence of ASCII bytes. You're going to have to write a function to go through that byte by byte and convert them to integers and store them in an array. And I'll talk quite a bit more about that later. Print the integers to the console, sort the integers using selection sort, print the sorted integers, and calculate mean, median, and standard deviation, printing out your results. I want you to use functions for each of these steps. First of all, write a function to read in that text file and place it in the buffer. 80-byte buffer should be big enough. And here I have some specifications about how to use the A registers and the V registers. I want you to write a function that will extract those integers from the input text buffer and store them in an array of 20 words. I have some helpful hints here in words, and I will go over that in a minute. Then you'll write a function to print the array of integers, write a function to sort them by selection sort. I have sample code in the GitHub for a bubble sort, and that may be helpful to look at. Here's an algorithm you can use for selection sort from Wikipedia, and the remaining functions are calculating mean, median, and standard deviation. And I again want you to use the A and V registers appropriately. You can use single precision float for the mean. For the median, you should write the function so that if the length is odd, it returns the middle value as an integer, and if the length is even, it averages the two middle values and returns that as a float. Then use v1 to be a flag to indicate whether the result was an integer or float. For this assignment, you can hard code the length as 20. Then you'll write a function to calculate standard deviation using this formula. And there is a square root instruction in Mars that'll be helpful. So basically you're going to loop through finding the difference between each value and the mean, squaring that and keeping a cumulative sum. Then divide that sum by n minus 1, and then take the square root of the whole sum. Here's the rubric, and here's a sample output. Here's the array before the sort, the array after the sort. Here's the mean, median, and standard deviation. A word of advice here. Mars will just work so much better if you put within a folder, here I just made a little folder called Homework 3, and I put in there my .asm file, my input file, and actually Mars. And when you open up Mars here, it just makes it easier for it to find the input file. I want to talk a little bit about the input buffer. So I've left aside 80 bytes for the array that I'm going to pick off. And 80 bytes is enough because there's 20 numbers. Each word integer takes up 4 bytes, so 80 bytes is enough. Hard-coded the length of my array and left space for mean, median, standard deviation. Here's my file name, which I've hard-coded. And then I want to start my input buffer. I want to start that on the next word boundary, so that's why I put on a line 2. And then at the very end, I put all of my prompts. I want to talk about what this input buffer will look like, and then how you go about extracting integers and putting them in this array space here. So I can find this in memory because it's right below input.txt. So let me assemble it and turn on ASCII, and I can see input.txt right here. Input.txt, I told it to skip to the next word boundary. So after I read in the buffer, it should start right here. Let me set a breakpoint after I read my buffer. and we can see what the words look like in memory there. So the first number is 18, and I have ASCII turned on, so that's 1-8, new line, 9, new line, 2-7, new line, 5, new line, etc. So given the start of the buffer, you can just go through a byte at a time and pick off the characters. I created this file on a Mac, and so that's why it uses the Unix style line return /n. If you open this file on Windows and accidentally save it, Windows might do something funny with the line endings. If that's the case, just re-download the file. This is just simpler to deal with. So this is what it looks like in ASCII. Let me turn off the ASCII, and we see the hex here. ASCII, all right, ASCII for 1 is 31, ASCII for 8 is 38, new line is 10, or A. You can see here that you can just go byte by byte through here, and if something is in the range 30 to 39 in hex, and I have in the instructions what those are in decimal, you can use hexadecimal to do this. What you would do is simply subtract 30 hex, or the equivalent in decimal, to convert this 31 to just 1. And then when you go to the next character, it's also a digit because it's in the range. What you would do is subtract 30. So now I've got this 1. I'm going to need to multiply that 1 by 10 so that it's 10, and then add the next digit. The next character is a new line, so I know that I'm done building this integer out of the ASCII. It's now 18, and I can store that in my array. Let me just go ahead and run the program so you see the sample run down here. You should get this number exactly if you follow that formula. Sometimes people forget to divide by n-1, and that would throw you off a little bit. This is our first fairly substantial program, and the key to this is just divide and conquer. Code up one function at a time. Make sure it runs by examining the contents of memory. Then go on to the next function. This function 2 that I just described about extracting integers from ASCII is one of the 2 challenging functions that you'll write. The other challenge is probably this sort function. The rest of these aren't that bad once you get into them. So there's 7 or so different functions. You definitely want to code up each function, test it, before you go on to the next function and the next one. This is a nice meaty assignment you can really sink your teeth into, and don't forget to post your questions on Piazza.